Alright guys, okay. Today we're going to have a look at chi-square with a basic example. So in the textbook we are using the first example in the textbook and we're going to walk through it. So guys, in the summary, what we want to look at with our chi-square is firstly that we want to say what is there an association between categorical variables? Categorical, so this is the Beat magazine, Grow magazine, and Youth magazine, and your genders. So the question that's being asked is there an association between gender and preference in magazines? Now this could help a company with their marketing strategy and all of that. So what we've got here is we have taken a sample, and our sample is our FO values, our observed values. Okay, so they give us a observation, and then we start following the 5 steps. Step 1 is define your null and alternative hypothesis. Your null hypothesis always is no association. Your alternative hypothesis is association. So you can say your null hypothesis is that there is no association between gender and preference. Your alternative hypothesis is that there is an association between gender and preference. Your second step is to get your area of acceptance and rejection. Remember, for chi-square, we are always working with an upper tail area of rejection. So what we do is we go and we calculate our degrees of freedom. This is a new formula for degrees of freedom. It's not n minus 1. And we say the number of rows, we've got 2 rows, female and male, minus 1 times the number of columns, minus 1. We've got 3 columns, 1, 2, 3, and that gives us 2 minus 1 times 3 minus 1 is 1 times 2. So we've got degrees of freedom of 2, and we know that our level of significance is 5%. Now we are working with a completely new table. This is table 3 in your textbook, and it is your chi-square table. Here you can see that it is an upper tail area of rejection, and we want to go to 5% and degrees of freedom of 2. And that will give us a value of 5.991. Alright, so hopefully everyone's comfortable on how to read this table. So we've got a chi-critical value of 5.991, and we know therefore, because it's an upper tail, anything bigger than that value will be rejected. Now, the next step that we are looking at is the most important step, is how do we calculate our chi-square stat, and what does it represent? So our chi-square stat represents the difference between what we observe and what we expect. Okay, so we've got our values that we've observed, but for us to say that there's no association, what values would we be expecting? And when I say expecting, what values will be a perfect world scenario of no association or perfect equality? Okay, so that was the formula that we showed a bit earlier, but basically how we calculate our FE, so this is our FO, observed, expected, is we take the same table, where we've got female and male, and we've got beat, growth, and youth, and now we want to say what is the perfect world scenarios. And how do we calculate this? The way we calculate this is to get this FE value. We go back to our observed values, and we say 80 times 46 divided by, what is our sample size? 200. Okay, so how it works is we take that value, and where they intersect, that will give us that expected value. So going back to our expected table, the first one would be 80 times 46 divided by 200. That would give us 18.4. The second one would be 120 times 46 divided by 200. So 120 times 46 divided by 200. So that times that over that will give us 27.6, and then so on. So to get this value, it would be 80 times 81 over 200 is 32.4, 46.6, 29.2, 43.8. And then, because you've done it this way, all your other values will add up to be the same. You'll still have a sample size of 200. You'll still have 46 beat preferences, 81 grow preferences, and 73 youth preferences. You'll still have 80 females and 120 males. So this is our expected values, and this is our observed values. Now what we want to do, as I said earlier, is we want to calculate what's the total difference between our observed values and our expected values. And is that difference so big or bigger than this value so that we should reject the possibility of no association? Alright guys, so now what we need to do is we need to restructure our table. And when I say restructure our table, we want to see our females and their preference for beat, growth, and youth, and we want to see our males and their preference of beat, growth, and youth. So we're melting down the table to have all of our options in the rows. Then we'll have our FO, our FE, and our FO minus our FE squared. And then what they did is they said FO minus FE squared over FE, which is your chi-square. Alright, so now let's look. Our female preference for beat is 13, female for growth is 39, female for youth is 28, male is 33, 42, 45. So those values come from here. Then for our expected values, for female it is 18.4, for growth it is 32.4, 48.6, no, sorry, 29.2, then it's 27.6, 48.6, and 43.8. So we've got our observed values, our expected values, and now we want to calculate the most important thing, is our chi-square value. So our chi-square formula is the square of FO minus FE over FE, and then the sum of all of them. So because I'm running out of space, I'm just going to do this and make this my chi-square. So this is my chi-square column, and then we say what is the difference between these two squared over FE, and then we get the following values: 1.585, 1.344, 0.049, 1.057, 0.896, and 0.033. And then if we sum all of these up, our chi-square stat is 4.964. Okay, now guys, this is very straightforward. So we know that it's an upper tail. We know anything larger than our chi-crit value, which is 5.991, will be rejected, and we can see our chi-stat value is smaller than that. It is 4.964, so it falls in an area of acceptance. So we compare them and we can say we are accepting our null hypothesis, therefore there is no association between gender and preference. Okay, so guys, that's a very basic example. I will do another one for you on a few more complex examples. Just want to note that it's exactly the same in terms of steps, but you take observed values. You need to know how to calculate your expected values. You need to be able to take both your observed and expected values and restructure it into a new table. Once you've got it in a new table, you want to calculate your chi-square value. The sum of them will give you your chi-square stat, and then you compare that value to your area of acceptance and rejection, and then you can therefore accept or reject your null hypothesis. Guys, I need to stress that your chi-square work is all rule-based. It's very easy to follow the rules. It's exercise knowing how to do the table work, and for the rest it's very basic arithmetic to add and multiply and deduct values. So make sure you understand these problems.